Hello everyone. So today we're going to say about SPC. SPC is nothing but statistical process control. Statistical process control is very important thing to control your process. So first of all, we need to understand that what is SPC. In SPC there is three terms is there: statistics, statistical, process and control. So what is statistics? Statistics is nothing but it is a way of getting information from the data. Process means it is a set of activities which convert input into output, and control means you have to control the process so that you can maintain the quality. So this is the three things that are involved in statistical process control: statistics, process and control. Okay. Now statistical process control, I have explained that statistics. So there are two types of statistics are there. One is descriptive statistics, another one is inferential statistics. So what is descriptive statistics? In descriptive statistics, we deal with less number of samples. Basically, in statistics, we take some samples from the population and we conclude over the entire population based on that samples. So in descriptive statistics, we deal with less number of samples. Samples are normally less than 50. In descriptive statistics, basically, we find out for the center tendency, we go with mean, median, and mode. And for the spread of the data, we go with range and standard deviation. Here, the standard deviation is S and variance is S square. Okay. Now, if my data is continuous, we find out basically here CP/CPK for the short term and PPK for the long term data. Okay. If the data is continuous, we will find out CP/CPK, PPK. But if my data is discrete, then here we find out DPU, defects per units, DPMO, defects per million opportunities, and PPM, that is parts per million opportunities. Okay, so these are all the things involved in descriptive statistics. So if I just make a summary, so here in descriptive statistics, sample size will be less than 50. In descriptive statistics, we basically find out CP/CPK, PPK. CP/CPK for the short term, PPK is for the long term. And if the data is continuous, but if the data is discrete, we find out here PPM, DPU, DPM. Okay. Now I'll move into inferential statistics. There are two types of statistics: descriptive statistics and inferential statistics. Inferential statistics is also called as probability statistics. Here we basically give the conclusion based on the entire big population. Sample size is more, it's more than 50. We go with the inferential statistics or for the probability statistics. Here we find out Z value. Z value is nothing but X minus mu divided by sigma. Normal distribution can be converted into standard normal distribution if my sigma equal to 1 and mu, matlab mean is equal to 0. Then Z value will be equal to X only. Okay, so Z value, the definition of Z value is that how many standard deviations the Z value is from the mean of the data set, that is equal to Z value. The important terminologies used in inferential statistics are basically your confidence interval, like a range of expected values, p values for significance level, sampling, selecting representative data, regression for relationship between variables. All these things are involved in inferential statistics, or it is also called as probability statistics. Okay. Now I'll move into data types, because in statistics we deals with data. Now there are two types of data: continuous data, or it is also called as variable data, and another one is basically discrete data. Okay, so continuous data examples means your pressure, your temperature, your length, weight, time. All these things are basically your continuous data. Why? Because time equal to 5.1 second, weight 75.5 kg, temperature 23.5 degrees Celsius. So all these things are continuous data. Okay. Now another type of data is there, that is basically discrete data. In discrete data means we basically find out number of defects: 10 defects, 20 defects, 5 defects, number of errors: 1 error, 2 error, 3 error, 4 errors, number of units produced. Okay, pass or fail. All these things comes under your discrete type of data. Now we need to control the process. So we need to understand how can we control the process until unless we know the control chart. So for this we require control chart. Now for continuous data, we basically find out X bar R chart, X bar S chart, and IMR chart. Okay, X bar R chart when sample size is less than 8. X bar S chart when the sample size is greater than 8. Normally, X bar R chart is used for smaller sample size. I have already explained. X bar S chart is used for larger sample size. And another thing is that is basically IMR chart, individual moving range chart, when the sample size is equal to 1. So it tracks the individual values and variation between consecutive data points. Now, control chart for the discrete data. For the discrete data, there are two things happen. One is defectives, another one is defects. So for defectives, we go with P and NP chart. P chart is for different sample size, NP chart is for same sample size. And for defects, we go with U chart and C chart. U chart basically for different sample size, C chart is for the same sample size. Okay, so that is how I have explained everything to you. That is basically we started with statistics, descriptive statistics, inference statistics, then we go with the data, attribute data, continuous data, and attribute data or discrete data. And we go with the process control also, where we've explained control chart for the continuous data, for the discrete data. So these are all the 9 different rules that I've given to you based on the statistical process control. Because until and unless your process is stable, you cannot do you cannot control the process. Process should be stable so that you can analyze the process, so that the process is in control or not. Okay. So if you found this video helpful, make sure to like the video, share this video, and comments below with your thoughts on statistical process control. Subscribe to our channel and turn on notification for more insightful content. So I just take the opportunity to thank you all from the bottom of my heart for being part of this journey. The lens is forward. So thank you so much.